Okay, question 13. The three forces F1, F2 and F3 are acting on a particle. So we got our three forces here. They're in vector form. So we're told that I and J are horizontal and vertical, respectively. The resultant of the three forces is F newtons. Part A wants us to find the magnitude of F to three significant figures. So, first of all, we get the resultant by adding all of the other forces together. So, F is F1 add F2 add F3. So, F is 25 minus 7 is 18, add 15 gives us 33i, and then for J, 12 add 5 is 17, minus 28 gives us minus 11j. So then the magnitude of F is the square root of 33 squared add 11 squared, which to three significant figures is 34.8. Cool. Okay, part 2 wants us to find the acute angle that F makes with the horizontal, giving our answer to the nearest 0.1 degree. So, we know that F is 33i minus 11j. If we make a sketch, then horizontal is like that. Now, our force vector is going 33 units to the right and 11 down. So our vector roughly looks something like this. We can make a right angled triangle. This is 33, this is 11, and this angle is theta. Then, using SOHCAHTOA, we know tan of theta is 11 over 33, which is a third. So, theta is the inverse term of 1/3, which to the nearest 0.1 degree is 18.4 degrees. Cool. Okay, then for the next part, the force, or the fourth force F4, is applied to the particle such that all four forces are in equilibrium. We want to find F4, giving our answer in terms of I and J. So, if the four forces are in equilibrium, then that means that the resultant is equal to 0. So, in other words then, F add F4 is going to be 0i add 0j. Now, we know that F is 33i minus 11j, therefore F4 is going to be minus 33i add 11j. Cool.